Alright guys, so in this video I am just finishing out a couple of examples in the notes. Applications of quadratic equations. For the majority of them, it's going to be easiest to use the quadratic formula. So if you need review on that, you need to go back to the prior section. In this video, the focus is going to be setting up the equations, not necessarily solving. The solving part goes back to the earlier sections where we just focused in on quadratic formula. So here's example 5 out of the blank notes. A manufacturing crew needs to assemble 4,200 boxes per daily, divided equally among the workers. So what that's just saying is we have all these boxes that need to be put together, and however many people are there, we're going to divide them up so that everyone's doing the same amount of work, ideally. One day, 4 workers call in sick, and the remaining members each need to assemble 120 more boxes than usual. How many workers in total are on the manufacturing crew? So I just went through and I wrote down a couple of things that we knew. So we know that there's a total of 4,200 boxes that need to get assembled, regardless of how many people are there. We know that it's going to be divided evenly among the people who are there. And then 4 workers called in sick. And so if I say that X is the number of workers on a quote-unquote normal day, then if 4 workers call in sick, I have X minus 4 workers that day. And then the remaining crew members need to assemble 120 more boxes than usual. So first, let's just talk about this divided evenly part. So divided evenly, I've got that the total number of boxes is going to equal, the boxes assembled are going to be the total boxes for the day divided by the number of workers that are there. So let's keep this thought going. This says that I have 120 more boxes to assemble because some people are sick. And so I can say that the boxes with the people being out sick minus the boxes on a normal day has to be 120 because I have 120 more boxes than usual. So that means now that I have these people out sick, I subtract off how many boxes each person is doing on a normal day, and that must be 120. And so now what we're going to do is we're going to write the boxes of the people out sick, which is going to be my 4,200, divided by the number of people I have on that sick day. Well, because 4 of them are out, I have X minus 4. And then the boxes on a normal day is still going to be my 4,200. And there I have X people because nobody called out sick. And that must be 120. All right, so I've got it written over here. So the boxes assembled on a sick day, 4,200 divided by X minus 4. Boxes assembled on a normal day, 4,200 divided by X. And then we just said that because I have 120 more boxes than normal, I can subtract those two, and that must be 120. And so this one is more complex in the solving. It goes back to chapter 14 as well. So I'm actually going to work on this one with you. And then example 6, I'm going to kind of just show you the work. And then that way you at least have it to go through and check. So I've got the problem written down again. And if you remember back in chapter 14, whenever we had what we called rational expressions, which just meant fractions with the variables in the denominator, whenever I had that, I had to multiply through by the LCD so that I could get rid of those fractions. And I multiplied through every single fraction. And so I'm going to have X times X minus 4, X times X minus 4, x times x minus 4. Now I've got some stuff that will cancel. X minus 4's will cancel. X's will cancel, and then nothing will cancel. So in that first fraction, I've got that 4,200 times x. Carry down my sign. 4,200 times x minus 4. And then here I've got equals 120 x times x minus 4. All right, get your calculators out because we're doing some really large numbers multiplying. All right, 4,200 times x is just 4,200x. I'm going to distribute this thing. Now make sure that you distribute the 4,200 and the negative sign, because minus 4,200 is the same thing as negative 4,200. So negative 4,200 times x is going to be negative 4,200x. Negative 4,200 times negative 4 is going to give me positive 16,800. Carry everything down. Oh, sorry, not carry everything down. Let's distribute that. Distribute this whole thing. And so I've got 120x times x is going to be 120x squared. 120 times 4 is going to give me 480x. All right, go through combined like terms. Well, thankfully, there is some stuff that will cancel. 4,200x minus 4,200x, those things are going to go away. I'll be left with 16,800 equals 120x squared minus 480x. Because I am solving with quadratic formula, I want to get the I want to get 0 on one side. I want to get all the variables and the constant on one side. So I've got 0 equals all this. Okay. Now I need to divide out a GCF, and I'm thinking that there is a GCF of 120. And so I'm also going to go ahead and rewrite it. I'm going to take this 0 and move it around back, just so I kind of shift that order to look more traditional. So I've got a GCF of 120, which is going to give me x squared minus 4x minus 140 equals 0. I can divide by that 120 and just kind of get that thing out of the way. Now from here, it's just a matter of quadratic formula like normal. So you're going to solve that all the way down, get your A, B, and C. And then when you get an answer, you're going to get a positive and a negative answer. Because x, let's go way back to my problem. Because x is the number of workers on a normal day, you're going to toss out that negative answer and keep the positive answer. And then that is going to be your number of workers on the manufacturing crew.